Welcome to Zona Mechanica. There is an MCQ on collision. Figure at the margin indicates the weightage of the question, that is 1 mark. A point mass having mass m is moving with a velocity v at an angle theta to the wall as shown in the figure. The mass undergoes a perfectly elastic collision with the smooth wall and rebounds. The total change, final minus initial, in the momentum of the mass is, there are four options: minus 2mb cos theta, 2mb cos sine theta, 2mb cos theta, minus 2mb sine theta. Well, in the figure, as you can see, this is the wall and this is the point mass of mass m, and the velocity is in this direction, making an angle theta with the wall, that is horizontal. Well, and this is the reference axis. This is x-axis, and the corresponding unit vector is I cap, and this is y-axis and the corresponding unit vector is j cap. The point to be noted here is that the options are given with unit vector j cap. See, all are having j cap. That means the answer is expected along y-axis. Okay, so let me draw once again. This is the wall and this is the velocity v. Okay, and this is theta. Okay, and I'm taking the axis over here. This is my x-axis. Okay, I cap, and this is my y-axis, j cap. Okay, so it is told that the mass undergoes a perfectly elastic collision with the smooth wall. Okay, so if it undergoes a perfectly smooth collision, that means the angle of approach will be same as angle of separation. See, this is theta, then this is also theta, and it undergoes collision over here, so it will rebound in this way. Okay, this is the initial velocity and this is the final velocity or velocity of separation. See, as the collision is a perfectly elastic collision, so there is no loss of energy. So whatever velocity is the approach velocity, that is the initial velocity, the same will be retained after the collision, that is the final velocity. The same, it will be magnitude of the final velocity is equal to the magnitude of the initial velocity. Only change will be in direction. And since the approach angle, suppose this is theta, so this will also be theta. Okay, if you consider this angle will be same. Okay, so what we have to do, we have to calculate the momentums along y-axis. Okay, so first this is the initial velocity, okay, in this direction. So if we resolve this velocity along y-axis, then what will be the component? This is theta, so this will be v sine theta, right? So this is the initial velocity along y-axis, and for this case, for the final velocity, velocity of separation, so this is theta, so this component will be v cos theta and this component will be v sine theta, and since it is along negative y-axis, so it will be minus v sine theta, right? So therefore the total change in momentum, so they told that final minus initial momentum. So that means final momentum is, this is the velocity, so, and the mass is m, so minus m into v sine theta, and this is minus, this is the initial what, this one v sine theta. That means the momentum will be m v sine theta, right? That is minus 2 m v sine theta. So the option D is the correct answer. Okay.